I know, I fixed it last night.
Alright, so let me get started again. Alright, so here we're going to talk about a section called law of sines and law of cosines. Let me just highlight this stuff. Like I said, the only thing you'd have to copy down would be what would be in this box right here. It says Mark lives in Valley Oak Hall at CSUN. So if you look over here, Valley Oak Hall is down here at this bottom piece. This is actually the map of CSUN's housing buildings. So he would live down in this building right here. He's able to walk in a pretty straight line to Lupin Hall to visit his girlfriend right here in the Lupin Hall building. And he measures it to be about 125 yards to that building. His sister lives in Southernwood, which is way over here on the other side of the building, housing buildings. How far is he from his sister and his girlfriend from his sister? So we want to know the two lengths here. We already have the one length. Now this is not a right triangle. So trigonometry was discovered and developed using right triangles. But it can be applied to other kinds of triangles as well. An oblique triangle, and I highlighted that, an oblique triangle is one that has no right angles. Any kind of other triangle, could be acute, could be an obtuse triangle, would be called oblique, because it does not have any right angles in it. Now the law of sines is used to solve oblique triangles. So not only can we use trigonometry to solve right triangles, we can also use trigonometry to solve any kind of triangle now. The nice thing about the law of sines is you don't have to worry about which two sides you have. The law of sines is just based on proportions. So you have the proportions right down here. The sine of angle A over the side A. Now remember, the angles are always capital letters, and the sides are always small letters. And the small letter is always across from its capital letter. So if I was to label this picture, and I was to say that that was angle A, and this was angle B, and this was angle C, then little a would be across, that would be the 125, would be little a. Little b would be across over here, and little c would be up here at the top, because it's across from big C. Sine of A over little a would equal the sine of B over little b would equal the sine of C over little c. These three ratios are all equal, so you can pick any two that you want and solve it. If we have A's and B's, then I would use this ratio right here. If I had B's and C's, I'd use this ratio right here. If I had A's and C's, then I could put the A's equal to the C's. It just depends on what we have. So kind of an information slide. We're going to move to the next one, and we'll actually figure out the distances for C and for A to find out how far he is from his sister and his girlfriend is from his sister. So let's check that out. Okay, so use it a lot. Let me label these again. This is angle A, angle B, angle C. This is little c up here. This is little b on this side. And little a is over here with the 125. Right now, I have angle A, which is 28 degrees. I have angle B, which is 50 degrees. And I have little a, which is 125. Is there any other piece of that triangle that I could figure out right now? Angle C, because what do I know about all three angles in every triangle? Add up to 180. So I can add these two together, that's 78. Take 180 minus the 78, and what do I end up with here? You get a 2, you get a 0, and you get a 1. You get 102 degrees. So angle C is 102 degrees. Now I need to find two of the same letter that I have. Which two do I have of the same letter? A's. I have angle A and I have little a. So I need to put that here. I need to put sine of 28 over 125. What that is that's the sine of A over the little a. That's what I just made there. That's one ratio that I could use. That's going to equal Now, I want to solve, let's say I want to solve for b. So I'm going to put a b on the bottom because I want to figure out what b is. If I want to figure out what b is, then I need to put the sign of b on top. So I need to put the sign of the 50 on top. Now it becomes almost all calculator work. Now you are going to show what you're multiplying, because to solve a proportion, you just cross multiply. So b times the sine of 28 would be 1. b times the sine of 28. The other one would be 125 times the sine of 50. 125 times the sine of 50. Now how do I get b by itself? Just divide by the sine of 28 on both sides. Divide by the sine of 28. Okay, so your b is now by itself. Now this is just what you're going to put in your calculator. Now let me show you on my calculator how it would work. And you can try it on yours. You should be practicing all these on your calculators, your phone or your calculator, or whatever it is you have. I'm going to put 125 times the sine of 50-degree angle. So 125 times the sine of a 50-degree angle. So look at the top of my calculator right here. 125 times the sine of 50. If I hit equals, that's 95.75. Now, I'm not going to put that down yet because I still need to divide it. I need to take this amount and divide it by the sine of 28. So divide that by the sine of 28. Whoops, my calculator just got weird somehow. 125 times the sine of 50. Do that first. And then I'm going to take this amount and divide it by the sine of 28. So you see how I did this amount divided by the sine of 28 equals, and that's 203.9. Let's just round that to 204 yards, just so we have whole numbers. So B is going to be approximately 204 yards. Let's put that on our picture as well. B over here would be 204 yards. So now we have little b, just by using a proportion. Just by using our calculators, we found b. Now I want to find little c. So to find little c, I need to do the sine of 102 over little c. I need to do the sine of c over little c. But I need to set that equal to one of my other ratios. Which one should I use? Sine of a over little a or sine of b over little b? It won't matter. You can pick. The reason I would pick a is because they already gave me a in the initial problem. So I would have put sine of a, which would be the sine of 28, over the 125 again. I'd use the same one they gave me in the problem. Would it have been wrong if I would have done sine of 50 over little b, which we just found to be 204? No, we could have used that too. But since they gave me a's, I'm going to use a. This would be the sine of a over the little a. Let's multiply our diagonals again. 125 times the sine of 102 equals c times the sine of 28. And then divide by the sine of 28 on both sides. So to get little c now, we're going to take the 125 here, times it by the sine of 102, and divide it by the sine of 28. Again, all of that's just going to go in our calculators. 125 times the sine of 102. So sine of 102 times 125, you can see that right up here, equals, you get 122.3, but I'm not gonna round that yet because I'm gonna leave it in my calculator, and I'm gonna just hit the divide button. So it's dividing this whole thing by the sine of 28. And you get your answer, 260.4, so we'll just leave it at 260. So which is farther away? What's the farthest away here? Who's farther from who? Is he farther from his sister, or is his girlfriend farther from his sister? His girlfriend's farther from his sister because 260 is across from the biggest angle, which was 102. Across from the biggest angle will be the longest side. Across from the smallest angle, 28, would have been the smallest side, 125. So that would be using law of sines. Now again, law of sines is simply setting up a proportion. That's what the law of sines is. Those are the two proportions that I set up to solve for b and solve for c. It's just cross multiplying. So law of sines is technically easier than SOHCAHTOA. You don't have to worry about what two sides, and you don't have to worry about SO or CA or TOA. You're just sine of A over little a, sine of B over little b, and then you can solve it. Let's look at another example. We can use law of sines if we've got two angles at one side like the previous problem. They gave us the two angles and they gave us the one side. We can also use it if they give us two sides and one angle. So let me show you how that works. If they give us angle U, that would be 42 degrees. ST would be 22, and SU is 12. This time they gave me two sides and one angle. Now you can always relabel these A, B's, and C's if you're comfortable. If you want this to be A, and this to be B, and this to be C, so you kind of know which one is which, that means that this would have to be little c up here, this would have to be little b, this would have to be little a, and you could then use your law of sines and cosines. Now, if I look at the ones I have, I've got angle C right here, and I've got little c. So that is one that I have to use because that's one that I have both of. Sine of 42 over 22. That would be like the sine of C over little c, or the sine of U over little u if you'd rather just use the u. But it's the same letter because it's an angle across from its side. So that one is one that we have to use. Equals. And this time I want to find angle T, or in this case it's angle B. And they gave me little b as 12. So I'm going to put the sine of B over 12. The 12 is our little b right there. 12 is across from this angle B. Notice that this time we're looking for an angle, not a sine. Remember what we do in our calculator to find angles? The little inverse, the little -1. You got to hit that second function and then the sign to get your negative. But we have to figure out what we're going to put in there first. So let's multiply our diagonal. 22 times the sine of B equals 12 times the sine of 42. Now I need to get the sine of B by itself, so I need to divide by 22 on both sides. So the sine of B, and let's figure out what this is. Let's get our calculator out. 12 times sine of 42. So there's my 12 times my sine of 42. I'm going to take this amount and I'm going to just divide it right now by 22. So just hit the divide button and hit 22. You should get a decimal of 0.3650 when you round it off. You should use 4 decimal points when you're putting it into the sign. That'll give you a more accurate angle. So now I'm going to take my calculator and I'm going to put in the 0.3650, hit my inverse and my sine. And it's going to be a 21.4 degree angle. Now you might have to hit the inverse sine first and then put in the 0.3650. You should, in both cases, get a 21.4 degree angle. Because we're using the -1 here. You could almost put a -1 right there to remind yourself to do the inverse. So angle B is 21.4 degrees. So that's this angle right here, 21.4 degrees. Could I now find angle S up here at the top, or angle A? Yeah, I could, because I know that 42 plus 21.4 is 63.4. And I'm going to take 180 and subtract 63.4 and get 116.6 degrees. So that's going to be this angle right here. Is 116.6. Now I've got all 3 angles. And I could actually find the other side as well just by using the law of sines. If I wanted to, I could do sine of, I won't solve it, but I'll set it up. Sine of 116.6 over little a, which I don't have, equals the sine of 42 over 22. And you could multiply your diagonals and solve for little a, just like we did earlier on the law of sines. So you could, if you've got 2 angles and a side, it works. If you've got 2 sides and an angle, it works. You could always go backwards and use the inverse to find an angle. So that's how law of sines works. It really helps us solve triangles that are not right triangles. Now we can solve any kind of triangle. We don't even need to have it to be a right triangle for us to solve it. The last slide for today is on an area. Area of a triangle. We have a formula that we always use, Old Faithful. Base times height divided by 2. Old Faithful works every time. But what if you don't have the height or the base? You got other pieces, like you got this triangle right here. It's not a right triangle, and you got kind of some random pieces. You could still find the area. We have a new formula based on our law of sines now. So with the law of sines, we've got a new area formula that we could actually use that'll make it easier. Let's relabel these just so you can know where A, B, and C is. Let's say that's A, and that's B, and that's C down there. So that means that this will be little c, this will be little a, and this will be little b right there. Now, if you notice the formulas, notice that each letter, A, B, and C, are always represented one time. You might have little a and little b and the sign of C, that would work. You might have little b and little c and the sign of A, and that would work. You just divide them by 2. You might have little a, little c, and the sign of B, and that would work. In our triangle, what do I have? I have little a, I have little c, and I have the angle B. So I'm going to be using this one right here. Little a times little c times the sign of B. So I'm going to use little a is 11 times little c is 21 times the sign of 35. And I'm going to divide that by 2. And that's going to be my area. If you don't do it this way, if you don't use this formula, then you have to draw in an altitude. You got to use that as the base. You got to use a 35-degree angle and trig to get the altitude, and then you can do base times height over 2, which will still work. It's just a lot more work than just plugging it into this formula right here. This formula will go a lot faster. So in your calculator, you do 11 times 21, and then you times it by the sine of 35. And then you take that amount and you divide it by 2. And now your area of this triangle is 66.2 square feet. A lot faster than drawing in an altitude and using the trig to find the altitude. And then you have the base times the height, and then you divide it by 2. You'll still get the same answer either way. This is a new formula that will save you some time if you use it. All right, that's part 1. We'll do part 2 tomorrow or next week.